Operational semantics. Intuitively, operational semantics of a language defines how the program written in that language runs. So for example, let's consider a Python program as following, that we'll see a function that called makeName, which expects three form argument: first name, last name, and gender. And then based on the three inputs, it will generate this salute based on the gender, okay, using the if-else statement here. And then it combines the salute together with the first name and the last name. So then as the entry point of the program, we expect three statements to capture the user keyboard input: first name, last name, and gender, and then print out the hello message by calling the make name function with the user input. But how this actually run in your computer during runtime? Is an imperative programming language. Typically, we follows the call stack semantics. So when a program was started, it will create a frame. Okay, in this case, the outer rectangle represents the outer frame of the call stack, and this denotes the execution of the main program, which is first we define the function makeName, followed by the for statement, where we capture the first name, last name, and the gender, followed by the print statement, will be executed in this order. So when it comes to the point where we try to call print hello, and intuitively we call the user-defined function makeName here, and we have to create an extra call stack frame, and by binding the formal argument fname with the actual argument fname, which is coming from the input statement, and same thing applied to the lname as well as the gender. With this new inner frame created, all the variable that defined locally here would not be able to reference by the stack in the outer scope. So the body of this makeName function will be executed in this inner frame. As this function finishes its executions, it returns a value and then back to the statement that it calls this function, and this frame will be deleted. Simple example, we show how a imperative language like Python can be modeled using the call stack. Typically in advanced programming, we have to deal with objects and some other data that will be allocated on ad hoc basis during runtime, and which would require us to use another execution construct called the heaps, which represent the segment of memory that are allocated for all these on-demand object allocations. In this case, we omitted over here. Next, we'll see how the runtime execution model can be different, and or even you say that it's simplified when we talk about functional programming language.